Okay, let's pick up where we left off of. This is part 4 in the series of taking the Swift tour. Swift, of course, the new programming language from Apple that is something worthwhile to take a look at, in my opinion, and possibly a really awesome learning tool for people learning how to code. Okay, so part 4, we're going to start with functions and closures. Use function func to declare a function. Call a function by following its name with a list of arguments in parentheses. And this is the symbol that we use that separates the parameter, which down here in the parentheses, that's the parameter for the function. And to the right of that symbol is the return type, which is a string. Okay, and then there's our brackets to create the block, and then this is what we're going to do in this function. We're going to return hello name. Today we are having a special. And I already went through and did the actual experiment on this, and of course this is the string interpolation, so that, for example, down here we can call greet, and I changed this to my name because I was doing the experiment, so I've kind of jumped ahead a little bit. And the special is lasagna. Okay, so that's how we got that over to the right. So basically we created a function that takes a name and a special, and it returns a sentence that have those items incorporated in. Okay, so let's continue. Use a tuple to make a compound value. For example, to return multiple values from a function. The elements of a tuple can be referred to either by name or by number. So here's another. Here we're going to create a new function called calculate statistics, and in the parentheses in this first parentheses to the left of this symbol is our parameter. What's our parameter? Our parameter is an array, and the array has the scores, and so we'll see that in a minute. In fact, let's just jump down for a second. We created this thing called statistics, where we call the function calculate statistics, and we pass in this array of scores. Isn't that cool? This is so powerful. And to the right of the symbol is what we're going to return, and we're going to have multiple returns. Multiple values returned from this function. Isn't that amazing? Which would include a minimum, maximum, the sum. Those are all integers. So we create our variables here, and this is just basic array syntax, where they're initializing min and max to the first value in the array. Is how I would attempt to say that, and we initiate sum to 0, so let's think about that, how that's going to work. Now we're going to loop. Okay, so for score in scores, so each one of these is a score, and the whole thing is the array scores, and the individual items in the scores array is a score. So if the score is greater than max, and initially max is going to be what? Not 0. Max is going to be at the 0 index position of the array, which in that case would be 5. So if score is greater than max, then max equals score. So for the first loop, it's not even going to do that. It's going to jump down to here. Else if score is less than minimum, if score is less than minimum. Now minimum is also 5. So neither one of these works for the first loop. Huh, that's weird, huh? Minimum score, and then sum is plus or equal to the score. All right. So that's what sum is going to do. Sum is going to, through each loop, it's going to add that value at each index as you loop through. So sum is going to accumulate. It's going to accumulate the sum of all those items in the array. And it's going to make these calculations that include min, max, and sum, and it's going to return those. Okay? Because we're still in the function. The function doesn't actually close to this here. Then down here, we're out of the function. We're going to go ahead and call the function with the function that is calculate statistics. So look how we do that. We declare a constant called statistics equal to, we call the function that we created up above, and we pass in this array. And then the function does its thing. Okay? And its thing involves returning the min, max, and sum, which is over here. The min is 3. Let's see if this makes sense. Yep, 3 is the smallest. The max is 100. Yes, 100 is the largest number. And what's the last one? The sum. So let's see if I can sum this really quick. So 5 and 3 is 8, so that's 108, and 3 is 111, and 9 is 120. Yep, that sound right? Okay, cool. So let's continue on. Functions can also take a variable number of arguments, collecting them into an array. Function, so we're declaring another function, and we're going to call this function sum of, and inside the parentheses is our parameter. And basically what this means is that you can pass in any number of items into this. Okay, that's the way I would say that. There perhaps might be a better way to describe that, but we'll see if it makes sense as we go. And then we're going to return a value that's going to be an int, and you can imagine what that's going to be. That's going to be the sum of whatever we pass in. So we set a sum, we initialize a sum variable to 0, and then we have a loop for number in numbers. Number in numbers, it's going to loop through whatever we pass in. That we're going, for each one of those, we're going to again use the sum syntax here. Basically what this means is that sum equals sum plus the number in that loop. So it's going to accumulate. And then return sum. Okay, just like similar to what we did before. The difference between the one we did before is the fact that here we can pass in any number of items into this, and I'll show you that in a second, I hope. Okay, and then down below here, this first item, we didn't pass anything in. So sure enough, sum was a 0. That would make sense, doesn't it? And the next one is we passed in, we called the function sum of to add these numbers up, and we passed in 1, 2, 3 numbers, and we got 651, and that looks good to me. Okay, now I'm going to just casually add another number. I'm going to add 100. Let's see what happens. Nothing so far. I was thinking it should. There it goes. It did it. It took a while for it to get it. But you see what happened? I was able to just add another number to this, and then it passed it through and bumped it up to 100. That worked. That's quite incredible, really. Look at the flexibility that gives you. We didn't have to rewrite this for more numbers or anything. It'll take whatever amount of numbers. I'll do it again. We're at 751. Now I'm going to put in another 100. It's going to bump it to 851. And this time it did it faster. I think I think that this is an incredible language. So, I don't know. I think it's impressive. And I like this playground environment. This is all, that's why I'm spending time with it. I hope that you get a benefit out of it too. So, experiment, write a function that calculates the average of its arguments. Okay, well, we know that we already have some, and we're going to need some, right? We're going to need some. And let's say, and I'm just going to kind of wing it here. We'll do, I've played with this before, so this is not the first time I've played with this. So let's see if I can do this correctly. So var av, why is it giving me a warning? Initialize the variable av was never used, consider replace. Okay, that's cool. That I'm all right with that because that just means I haven't used it yet. For number and numbers, sum equals that's what sum equals. Okay, I get that. And so now I want to do a collection for average. So my question would be, where do I put that? I know how to do an average, right? I could do it average. Well, see, I don't want to do it there because I think what I want to do is maybe do it down here. And the average will equal the sum, right, divided by what? Well, I think we almost have to have the number of you might get this quicker than me. I'm not the fastest light bulb in the knife drawer, if you will. So I think we're going to need something that keeps track of the iterations, the indexes. So how could we do that? Index equals, well, it's going to be similar to this. I don't know. Is this going to work? Index equals, it equals what? How about this? Sum I equals sumi equals I. All right, and so what that's doing is that's, I hope, is accumulating just the indexes, okay? And now I'm going to put sumi in. That would be great if some of these errors would go away, but I'm not sure that they're going to. Yeah. So what it's going to say here is oh, can we do it this way? Let's say I equals I plus 1, so that each time it'll add to that. Will that work? Now, what is it? What? Okay, so that error went away. And average equals I. All right. And now that one went away. Huh. Average equals sum divided by I, return sum. No. Return yeah. Okay, so see what I'm doing? I'm totally changing this. Instead of sum, it's going to be sum of, average of. I don't know if this is going to work or not. Huh. So no, it didn't like that. Well, average up. Well, it sure didn't like any of that. So let's see. Huh. You know what would be cool if I could reset that file. If I could reset that. Oh. So you see what I did? I hit the backspace and then I came back. And then let's come down a little bit. Oh, we still got a problem here. And have of. And we're going to pass these things in. Yeah, I could see where av of 0, that's not going to work because it's not going to loop. Oh. Wow. That looks like it might be right. So let's see. What would be the average? Let's do something that we know the average of. What would that be? How about 4, 6, and 8? 4, 6, and 8. The average should be 6, right? Guys, that looks like that's working. Okay. Now, average of 0. We're not going to be able to do that because if you do that, I could see where that could be a problem because you'd be trying to divide by 0, and that the computer's going to have a problem with. All right, so that's probably what happened there. But this looks like this is working. Let's move on because got kind of in the weeds there a little bit. It'd be nice to move on. So I told you functions are a little more challenging. Hey, the other thing that I was thinking we could have done here was create a brand new function. Rather than changing the sum of function, we could have left the sum of function and we could have used the sum of function as a parameter. So it would have been a function so that our average of called sum of, passed the numbers in, and then got a return value, which would have been the sum. So I'm hoping that they show that to us here a little later on. Okay, that's a little more sophisticated. So I'm glad I didn't try to do that here. But just to give you a heads up that that's definitely possible. It's more than possible. That's something we want to learn. Okay, so we did the experiment and we calculated the average. Functions can, right away. It's getting into it right away. Just what I was describing. What a nice segue. Functions can be tested. Nested functions have access to variables that were declared in the outer function. Nested functions have access to variables that were declared in the outer function. You can use nested functions to organize the code in a function that is long or complex. Okay, so that's exactly what we're talking about. So we're going to create a function called return 15. We're not passing any parameters in. We're going to return an integer. We're going to initialize a variable y. We're going to have a function that we're going to call within the function. A function within the function. We're going to call the add function. Okay. And in the add function, here's what it will do. It's going to add 5 to the y. The y is 10 here. And so then it's here we so this is where we describing the function, creating the function. This is where we call it. Okay, we call the add function. All right, and then we return y after it adds. So that's kind of slick. Okay, that's getting some sophistication going on. And then here finally we get completely out of the return 15 function, the initial function, and then we call it return 15. And the way this is set up really simplistically, because you would never write a function like that where the numbers are fixed. You want to be able to pass numbers into a function so that the function can be used in any case. So in different cases. So functions are first class type. This means that a function can return another function as its value. Indeed it can. And so function make incrementer. All right, so we're declaring a function. It's going to return, wow, this is getting weird now. It's going to return, what is that? An int function that then returns an int. All right, a function can return another function. See, this is to the right, and that's what they're saying here. You can return another function as its value, and that function can also return an int. So this gets a little weird. Here we go. So here's the function add one number that returns an int. Okay, so this add one number that returns an int, I'm assuming that that's here. That's what this is to the right of this symbol. Okay, and I'm thinking that's pretty good observation, or if you want to say guess, fine. And then that function, the add one function, returns 1 plus the number. Okay, and that's, yeah, that makes sense there. It returns 1 plus the number. So it performs an increment function, increments it by 1. And then we return add 1, okay, once we pop out of that. And then, so here's, we're going to create a incrementer variable where we call make incrementer, okay? And so then once we have that, we're going to call increment and pass in 7. Pass in 7 where? Well, we're passing it up here to our make incrementer function, which we renamed increment. See what's going on there? So what's happening is we call make incrementer, we pass in 7 in this case. Okay, and then that's going to return a function which returns an integer. Wow, that's weird, huh? The function add1 number, so our number is 7, and it's going to return an integer. So it's going to, that integer is going to be our number that we passed in, which was 7, plus the 1. So if you can see, sure enough, over on the right, the result is 8. Return add1. Yeah. All right. So just go with that for the moment. Let's continue. A function can take another function as one of its arguments. Okay, so now we're going to declare a new function. All right, and we're going to, the parameters are going to be a list and a condition, and it's going to return a Boolean and that is weird. It's a little weird, isn't it? Return a Boolean, which returns a Boolean. So, okay, that's hard to read or wrap your mind around. Let's just jump into the code. So we're going to go into a loop for item in list. If the condition item is true, then we're going to return true. Else, we're going to return false. That's our loop. Okay, so here looks like we're going to test it here. Let's see. No, maybe not. So function less than 10. Number, return a bool. Return number is less than 10. Okay, so this function less than 10, it's going to return a Boolean, so that'll be true and false based on whether the number is or is not less than 10. Okay, going down, the next variable is we're going to create a variable array called numbers. And then finally, we're going to call our as has any matches function, and we're going to pass in numbers, which is this above, that's that array, and a condition, which is less than 10, which we have identified here. Okay, so what do you think is going to happen? Well, it's going to return true because when it calls has any matches, when it calls that, it's going to pass in numbers, which is this array. Notice this array has a 7 in it. That's less than 10. It passes that in. That's here. That's the array. And the condition is that it's less than 10. That's what this is. So this is a problematic one. This is one that well, I just bumped it. I bumped the scroll wheel, and that got me screwed up here. So let's see if I can find it again. So has any matches, passes in numbers, and it passes in the condition. The condition is less than 10, and here it is. And of course, 7 is less than 10. Pardon me. And so it's going to return a Boolean, which in this case is true because yes, indeed, there was a number less than 10 in the array that we passed through. And okay, so I hope you get that. I don't want to dwell on it. I want to just keep going. Functions are actually a special case of closures, blocks of code that can be called later. The code in a closure has access to things like variables and functions that were available in the scope when the closure was created. Even if the closure is in a different scope when it is executed, you saw an example of this already with nested functions. You can write a closure without a name by surrounding code with braces. Use in to separate the arguments and return type from the body. So here we go. Numbers.map. And they're saying that this is a... Are they saying that this is a closure? Okay. Parentheses and then the brackets. You can write a closure without naming by surrounding code with braces. Oh. Okay. So, int. Return type is an integer. Let result as constant equals 3 times the number. Return result. And you might think, well, where's numbers? Well, they're still going to use numbers up here. All right. So, how does that work then? There's, oh, look what happened. Number int. So what happened was we passed the numbers parameter in, the numbers array in, and then we performed this multiplication where we multiplied it by 3. Right? That's what happened. Look, 60 times 3 is 20. Huh. So it's not a loop per se. Things like verbs. So there you go. Experiment. Rewrite the closure to return 0 for all odd numbers. Ooh. To return 0 for all odd numbers. Well. It would have to say you could say something like this. It would be one way to possibly do it. If number in numbers. Yeah, this is tricky. I'm not exactly sure how to do this. How could you do that? For all odd numbers, that means, for example, if you did a modulus that if something was left, if you had a remainder in a modulus division, and that would mean it was odd. Huh. So if all right. Okay. Else return true. Something like that. I'm kind of just winging it here, pseudocode. how do we say same as? Huh. Okay, so I'm not really sure how to do this one. So this is not going too well. Let's get rid of all this and start again. That's one thing with this Swift, you know, we're doing the whole thing in one shot. So I can't just I could reset the whole thing, but we'd be starting from the beginning. Then I'd have to come back. Whereas it would be great if I could just restart the initial problem that we're working on without having to remember how it was set up initially. So let's try this again. Let's access things like variables and functions available in the scope where the okay. You can write a closure without a name by surrounding code with braces. Okay, so that's what we've done there. Use in to separate the arguments and return type from the body. Okay. So that's what in does there. And what happened here was we have this map closure. It's kind of like a function. And what do they want us to do? They want us to rewrite the closure, return 0 for all odd numbers. Ooh. Right? Let result equals 3 times the number. Well, if we took the number excuse me. You know what? I might come back to this one. I'm kind of stumping on this one at the moment. So this will be something we can revisit. Okay, it says you have several options for writing closures more concisely. When a closure's type is already known, such as callback for a delegate, you can omit the type of its parameters, its return type, or both. Single statement closures implicitly return the value of their only statement. So here's map numbers equals number.map, number in 3. Yeah, so what they've done here is they've eliminated the parameter types, because it's, you know, 3 is just obviously an integer, for example, times number in 3 times number. Okay, I get that, sort of. And yeah, see up above we're returning what numbers map did up here was multiplying each number by 3. You know, it's weird. It loops through it on its own, doesn't it? There's no loop written, but it does it on its own. That's a little bizarre. That's so I'll have to wrap my mind around that as well. Numbers.map. Huh. All right. You have several options for writing closures more concisely. When a closures type is already known, such as the callback for delegate, you can omit the type of its parameters, its return type, or both. Single statement closures implicitly return the value of their only statement. Okay, let's see if let map numbers equals numbers.map number in 3 times the number. Yep, and print map numbers, and it's the same. Okay, so they just consolidated their syntax to make it less wordy. Okay, that's cool. Print map numbers. You can refer to parameters by number instead of by name. This approach is especially useful in very short closures. A closure passes the last argument to a function. A closure passes the last argument to a function can appear immediately after the parentheses. Argument to a function can appear immediately after the parentheses. You can refer to by numbers instead of by name. This approach is especially useful in very short closures. Closure passes the last argument to a function can appear immediately after the parentheses. When a closure is the only argument to a function, you can omit the parentheses entirely. Okay, so let's see if we can understand what they're talking about there. Let sorted numbers equals numbers.sort. And then they just show that that 0 is greater than 1. Okay. And then print sorted numbers. So they're going to take the numbers array from up above, and now they're going to sort it from high to low, it looks like, huh? That's kind of interesting? From high to low. What if I switch this around? Oh yeah, so the smaller number is greater. It shows up further along than the larger number. Now I could switch these and now I just put it in reverse order. Haha, cool. Okay, we're going to take a break. Now then we'll come back and do objects and classes. Thank you.